Kristen.
It's astounding.
I'm Amy.
I'm
Melinda.
And I'm Lindsay, and this is our clock that's going to be destroyed.
Takes its
This is our quartz crystal clock in working order
but
before
listen
dissection.
closely.
Not for very much longer.
I've got to keep control. I remember doing the time war, drinking those moments when the blackness would hit me and the void would be cold.
To figure out how our clock works, we first open it up and take a look at the inside. Here's a view of the working innards of a quartz crystal clock.
It's just a jump to the left. With your hands on your hips.
It's so dreamy. Oh, fantasy, free me. So you can't see me. No, not at all. In another dimension. With voyeuristic intention. Well secluded.
Here are all the disassembled pieces of the clock.
The face and hands of the clock, shown here, make up the time indicator.
This is the outer case of the clock, which holds everything together and shields it from the outside world. This is the battery, which powers the clock and the battery contact strip. Here's a close-up view of the microchip circuit. Two of its important features are the copper coil and the quartz oscillator.
These pieces make up the electric stepping motor, or the clock's escapement. The little silver tube contains the vibrating piece of quartz, which is the clock's regulator. When the copper coil is powered by the battery, it becomes an electromagnet. The little magnet attached to the tooth wheel is the rotor. One side of the magnet is attracted to the electromagnet and one end is repulsed, so the magnet turns to orient itself with respect to the electromagnet. The shape of the metal strip determines which direction the magnet turns.
If you look closely, you can see that the little metal strip is not perfectly symmetric. We found out the hard way that if you put this piece in backwards, the clock will run backwards. That was a surprise.
When the quartz vibrates, the microchip counts the vibrations and translates them into electrical impulses that occur every second. These impulses change the polarity of the electromagnet, which then forces the rotor to turn again. This process repeats over and over again, so the rotor keeps turning. When the rotor turns, it causes the rest of the gears in the gear chain to move. This gear, at the end of the chain, attaches to the hands of the clock and moves them around the face. This little wheel and post allow you to set the time on your clock.
Here's how everything works together. The quartz oscillator receives power from the battery, which causes the piece of quartz to vibrate. Larger pieces of quartz vibrate more slowly, while small pieces vibrate quickly, but any given piece of quartz vibrates at a constant number of times per second. The microchip circuit counts the number of vibrations and turns them into electric pulses, which occur once per second. These 1-second electric pulses are transmitted to an electric stepping motor, which converts the electrical power into mechanical power. The stepping motor is attached to a toothed gear, which is the first in the chain of gears that moves the hands of the clock around the face at the correct rate.
Time, love, time, love, time, love. It's only a change of time.